Okay, once again, my name is Deodat Joseph. I'm here today for solving paper 2 of biology.
Okay, once again, my name is Deodat
2019.
I'm here
Paper 2
today.
is paper 2 consists of section A, B, C, and D with the total of 8 questions, and the student or the candidate is supposed to answer 5 questions, at least 1 question per each section. So each question carries 20 marks. So section A, we are going now to start with the part which is comparative study of natural grouping of organisms, that is classification. There is this question which says describe the distinctive features of classes of phylum Arthropoda. Okay, the distinctive features of phylum classes of phylum Arthropodas. Okay. Phylum. Phylum Arthropoda. This phylum Arthropoda consists of the following classes. The first one is Insecta. Second one, Crustacea. The second is Arachnida. The fourth one is Chilopoda and Diplopoda. Okay, these are 5 classes in the phylum Arthropoda. So let us start with the distinctive characteristic of Insecta. Okay, Insecta. Okay, the class Insecta. The class Insecta has the following distinctive characteristic. This is not general characteristic, but the distinctive characteristics. Okay, their body are divided into 3 parts. Body, okay, are divided into 3 parts. That is head, thorax, and abdomen. Okay, this is the first one. The second is the 3 pair. Okay, 3 pair of walking appendages. Okay, all of these 3 pair of walking appendages occurs, okay, in the thorax. Okay, the third characteristic is that they have 1 or 2 pairs of wings. Okay, wings. So when you mention the Insecta class, you have 1 mark, and all these 3 points, you'll have 3 marks on that one. Okay, that is how. Okay, now let's go now to another class, that is Crustacea. Okay, The second class is Crustacea. Class Crustacea. Okay, class Crustacea. It is not crustaceans, it is class Crustacea. Okay, this one has the following distinctive characteristics. Okay, two pair of antennae. Okay, the first one is two pair of antennae. Okay, antennae. Then they have the second characteristic is compound. Okay, they have a pair. A pair of compound eyes, okay, which is raised on stalk. Okay, raised, okay, on stalk. Okay, this is very important. They all, because all organisms, they have compound eyes, but the distinctive, to show that the distinction of their eyes is raised on the stalk. Then they have five. The third characteristic, they have 5 or more walking appendages. Okay, so as this one has 1 mark, this 3, okay, this 3 has 3 marks. Okay, so if student you answer it well, you get like that one. Okay, and let's go now to another class, that is Arachnida. Class Arachnida. Okay, class Arachnida. Okay, under this class Arachnida, we have an example here of the organism which is here is like organism like ticks and so on. So under this one we have the following characteristics. They have 4, this one 4 walking appendages. Okay. The second characteristic is that 1 pair of chelicerae, 1 pair of chelicerae. Okay, this one, or it is known as all fans, for capturing, okay, capturing food or prey, capturing food, prey. Okay, so they use that one for capturing prey. Okay, another characteristic of this group, they do not have the antennae. Okay, do not have antennae. They do not have the antenna. Okay, antenna. Another is that under this one, they use book. They use book length, okay, as surface for gaseous exchange. Okay, so as normal here you get 1 mark and you can choose 3 among the following, okay, which is 3 marks. 3 among those answers. Okay, another is class the Arachnida is Chiropoda. Chiropoda, class Chiropoda. We know that under Chiropoda we have organisms like centipede. Okay, class Chiropoda. Okay, the class Chiropoda. Yes. Okay, sorry. Here. Okay, it is single L. Okay. Chiropoda. Under this one, we have an organism like centipede here. Okay, centipede. Okay, the distinctive characteristic under this group, dear viewers, is as follow. Okay, the flattened body with one pair of walking leg per segment. Okay, one pair. Okay, pair of walking appendages. Okay, walking appendages. Okay, per segment. Per segment. Okay, one pair of walking appendages. The flattened body with one pair of walking appendages per segment. Then they have poisonous claw at the posterior appendages. They have a pair of poisonous claw. Okay, poisonous claw. Okay, at posterior posterior appendix or a posterior segment. Okay, they have one pair of poisonous claw. That one is for protection, and so they mainly two characteristics. Okay, and that is distinctive under this one. If you just mention this one, you have one mark, and these two, okay, it is 0. It is 1.5 mark, 1.5 mark. So you'll have that marks. Then the last class under this question is Diplopoda. Is class Diplopoda. Okay. Okay, class Diplopoda. Okay. This class Diplopoda, diplo means two. Okay, this one consists of organisms like the organism which is under this group. First of all, the characteristic. Let's go to characteristics. The following distinctive characteristic under this. The first one is they have cylindrical body with two pair of working appendages per segment. Okay, two pair of working appendages. Okay, per segment. Okay, and this is why they are called, okay, diplopoda. So in one segment they have two pair of working appendages. Then they have this characteristic, okay, the characteristic of coiling themselves, and they coil themselves and producing a poisonous liquid. Okay, this one, the poisonous liquid is known as hydrocyanide. Okay, hydrocyanide. Okay, to keep predator away. To keep predator away. Okay. Okay. This they have these two distinctive characteristics. Okay. If candidate you'll mention this one. Okay. Here you'll have 1 mark, and here 1.5, 1.5. So that is about the phylum. So that is about our first part, question 1, part 1, which says describe the distinctive characteristics of classes of phylum Arthropoda. Okay, part 2. Okay, question 1. Okay. That is the end of question number 1. So question number 2. This question number 2. Okay, question number 2. Still this question is under section A, which is in the comparative study of natural grouping of organism. This question says how, question number 2A say how the gymnosperms and angiosperms bear seeds. Then why are they classified separately? The gymnosperm and angiosperm bears fruits, seeds. Then why are they classified separately? And part B, differentiate maize plant and bean plant basing on the following headings. The first one, okay, let me repeat. Differentiate maize plant and bean plant basing on the following heading. Okay, first one, leaf morphology. stem anatomy. Roman 3, root morphology. Roman 4, seed morphology. And Roman 5, flowers. Okay. Let's start with why gymnosperms and angiosperm both bear fruits, but then why are they classified differently? Okay, under this one, I'll put like in this table, like this one. On this side, angiosperm. Okay, and this side, gymnosperm. Okay. The angiosperm are all flowering plants, okay, while gymnosperm, that one do not produce flower, like conifers and, for example, like Christmas tree and so on. But on this side, all those which are producing flower. Okay. The first one, why are they classified differently while both of them bears fruit, bears seeds? The first one is about the xylem. Okay, this is vessel for transporting raw material from the soil up to the plant. This on this side, on angiosperm, it consists with vessels and phloem. Okay, the phloem, this is the vessel which transported food which is manufactured to different part of the plants. This one consists of companion. Okay, have companion cell. Okay, this is our first characteristics. While in the gymnosperm, here xylem have tracheids, okay, but not vessel. And phloem, okay, this one do not have companion cell. Okay, so it's good to make the difference that kind. Okay, the difference number 2, why are they classified differently, is that the seed are enclosed in the fruit wall under angiosperm. Okay, seeds. Okay, this one are under fruit wall. Okay, wall. Okay, but on this side, okay, under this side, just consists of naked seeds. It means the seeds are not enclosed in the fruit wall. Then number 3 is that why are they different? Is that this one double fertilization. Present. Okay, while on this side, okay, do not have. Okay, double fertilization. Okay, do not have double fertilization. Okay, this angiosperm produces flowers. Okay, flower for reproduction purpose. On this side, okay, has cone, okay, for reproduction purpose. Okay, for reproduction purpose. And the lastly, dear viewers, they have smooth leaves which are flat. Okay, this has flattened leaves, okay, which are smooth. Okay, while on this side it has needle-like, scaly scaly leaves. Okay, so these 5 differences, each of it has, okay, 1 mark. Okay, on this side 1, and total of 10 mark per these all differences. Okay, so dear viewers, that is how you can differentiate gymnosperm and angiosperm. Okay. Okay, so that is our the second question, part A. We've finished about the difference between angiosperm and gymnosperm. Now, question number 2B, which says that how B, differentiate between maize plant and bean plant based on the following heading: leaf morphology, stem anatomy, root morphology, seed morphology, and flowers. Okay. Okay, how to differentiate those? Okay. 2B. Okay, about a bean plant. Bean, okay, plant, and maize. Plant. Okay. Okay. We know that the bean is, okay, this one is, all of them, maize and bean are angiosperms. Okay, this one is under dicotyledon, and that one is under monocotyledon. So their differences is as follow because under that criteria. Criteria number 1, it says leaf morphology. Leaf morphology. Okay, leaf morphology. Okay, leaf morphology criteria number 1. Okay, and bean plant, this one has net venation. Okay, while on this side, okay, this side and this one has parallel venation. Okay, that is under leaf morphology. The second is stem anatomy. Anatomy. Under this one, we have like 2 differences. Okay, this one is that this one has bean plant has ring vascular bundles. Okay, and it consists with also it has a vascular cambium. Okay, for secondary growth. Okay, you have to write secondary. Okay, for secondary growth. But on this side, okay, the vascular bundle, okay, vascular bundle are scattered. Okay, and do not have vascular cambium. Okay, except in coconut. Okay, so this is why they do not have secondary, okay, growth, and mainly these are on monocotyledon. They consist of herbs. The second and the third difference is the root criteria, root morphology. Okay, root morphology. This one consists of, okay, of taproot. Okay, with lateral with the lateral roots. Okay, under that one. Okay, but maize, dear viewers, it consists with adventitious roots at the bottom of shoot. Okay, forming fibrous. Okay, fibrous root system. This forming fibrous. Okay, fibrous root system. Okay, fibrous. So that is how they differs. Under seed, criteria number 4, seed anatomy. Okay, or seed morphology. Yes, morphology. Okay, the embryo consists of, okay, consists of two cotyledons. Embryo consists of two cotyledons. Embryo consists of, okay, here consists of two cotyledons. One consists of, okay, and the last one is fluoroparts. And this one it has four, 2, 5, what is fluoroparts? Parts. This on this side it is, okay, it is 3 fluoroparts. Okay, so this is how question number 2, how being planted maize plant differs. Okay. Now let's go to question number 3. Question number 3. Illustrate your answer fully with the appropriate genetic symbol. Question number 3b. The ability to test the chemical phenyl thiocarbamine is autosomal dominant phenotype. Inability to test it is recessive. If tester woman with non-tester father marries a tester man who is in the previous marriage has non-tester daughter, what is the probability that their first child will be non-tester girl? Part 2, Roman 2, a tester girl. Roman 3, a tester boy. Part C, question number 3, what is probability that their first 2 children will be tester of NSX? Okay, so question number 3, part A, let's do this. Why it is not possible, okay, to use homozygous dominant organism in the testicles. Okay. 3 A. Why not possible? Okay, using homozygous, okay, dominant. Okay, character or character, okay, in the testicles. Okay, first of all, we know that the testicles, this is the breeding between individual of unknown genotype with unknown genotype with the dominant phenotype with individual which are recessive phenotypically in order to determine the genotype of the individual. So the test cross, it helps us to know the genotype of the dominant organism, which shows a dominant phenotype character. So why it is impossible to use homozygous dominant character, okay, to do the test cross, okay, is because it is because all the offspring will be with the dominant. All offspring will have dominant, okay, dominant, okay, character. Okay, let us illustrate this one. Okay, if you answer the question like that, you'll get 1 mark. So all of the individual will show the dominant character. Okay, the illustration. Okay, let's say, okay, case 1. Under this case, let's say the individual with the dominant character is homozygous character, okay, in the case 1, okay. Let's T, okay, represent, okay, tall allele, and small t, short allele. And this first case, let's say that the individual, the phenotype of the individual are homozygous. Okay, the phenotype, sorry, is it is tall. It is tall individual breeded with tall, which is homozygous, which is used in the testicles. That is why it is not possible to use homozygous tall. Okay, the genotype will be like this one. Okay, if this one is homozygous, it will be TT, okay, individual. And this one, homozygous, which is used in the testicles, and it is impossible, will be TT, okay. Meiosis will occur, okay, like this one, okay, to form gametes here, to form the gametes, okay, and this one is gametes, okay. Now fertilization, random fertilization will occur here. That is, this one will fertilize that one to form TT, and this one will fertilize this one to form T, capital T, and this one with this T, capital T, capital, and this one and this T, capital T, capital. It means the offspring genotype genotypes all are tall homozygous, okay, tall homozygous tall, all are homozygous tall. And offspring genotype, okay, then offspring phenotype. The phenotype, all of them are tall. So this is case number 1. Case number 2, Okay, let me use here. Case number 2, now, case 2, let now the individual of a known genotype is heterozygous. Okay, that is the phenotype. I will just go this way. The phenotype is T, that one, is test-crossed with the dominant. Okay, T, that is dominant, which is not, cannot be used in the testing. The genotype, okay, the phenotype, the phenotype here, okay, the phenotype is, both of them are tall, but the tallness here, we say that this is our case 2, is the genotype is this one, heterozygous tallness, and is crossed with homozygous as test cross, homozygous tallness. Okay, the meiosis will occur as normal, like this one, T capital, T small, that is gene for that one. This one, T capital, okay, and random fertilization will occur, okay, as here, okay, this is gametes, that is T capital, T capital, T capital, T small, and T capital T small. So it is, as you can see there, the genotype, all of them are, there are 2 genotypes here. The first one is homozygous tall and heterozygous tall, but the phenotypic, all of them will be looking tall. Okay, so it is impossible, or it is it is impossible to use dominant homozygous for test crossing, as you can see. Okay, it is very important on answering this question, student, to show this relative. Okay, it has its marks. For example, if you left like this one has 1 mark. If you separate like this one, the phenotype, genotype, or meiosis, and so on, total of this one, it has 4 marks. Okay, and this one, okay, don't do like this one. You have to separate, starting again homozygous, phenotype, genotype. You have to show like that one. Also, this one will have 4 marks that way. So it is very important to show everything. Don't just cross. Okay. So it is impossible, as you can see here. Okay. Let's see. Okay. Question number 3, part B. It says ability to test a chemical phenyl thiocarbamide is autosomal dominant phenotype. Inability to test is recessive. If a tester man with non-tester father marry a tester man, if a tester woman with non-tester father marry a tester man who in the previous marriage has non-tester daughter, what is the probability that their first child will be non-tester? Okay, Roman 2, a tester girl. Roman 3, a tester boy. Okay, that is the tester, okay, is dominant. dominant character. Non-tester, okay, is recessive. Okay. They say this woman, his father, her father, the woman, her father is non-tester, but the woman is tester. It means the woman father is non-tester, and okay, that one. This shows that this woman is heterozygous because the father is non-tester, and we know that non-tester is recessive. So the woman is heterozygous tester. Okay, tester. Okay, this woman, okay, married the man who in the first marriage has non-tester daughter. Okay, man, first marriage, okay, has non-tester, okay, non-tester daughter. Okay, daughter. Okay, if the man who is tester, okay, the man who is tester but has non-tester daughter, and we know that non-tester is recessive, it means also this man is heterozygous tester. Okay, so if we can show that, we can do this one. Let A, this one represent allele for testing. Okay, testing, and A small, okay, represent allele, okay, for non-testing. Okay, non-testing. Okay, so okay, let me do it here. Okay, the woman here, woman versus man. Okay, the woman, it is heterozygous tester. It means is tester. Okay, this is, sorry, the phenotype. Okay, let me, okay, so that I can write it well here. Here, this one is, you have to show it well. Phenotype. Phenotype. They are tester, and this one is also tester. Okay, the genotype. The genotype, since as we have already established here, they are all heterozygous. It means as we have already let it. Okay, so it is heterozygous. It is A, capital A small, and A, capital A small. Okay. Now, formation of gametes by meiosis. Okay, it will be like this one, A small. Okay, that one, A small, like that one. Okay, random fertilization. Okay, the random fertilization will occur like this one, dear viewers. Okay, this and that one will form tester one, and this one and this will form a tester which is heterozygous, This one and this is tester but heterozygous. This one and this, it will form, okay, non-tester, which is hetero. It is homozygous recessive. So this is genotype. Okay, the genotype of offspring genotype. The phenotype is that 3 out of 4 they are tester. This, okay, dear viewers, and non-tester phenotype. This, okay. Non-tester is 1/4, only this one. Okay, 1/4, this one is non-tester. Okay, so the probability is 1/4 will be non-tester, but 3/4 will be tester according to that one. So the question says like this one, okay? It says, what is the probability in their marriage, okay, to produce a non-tester girl, okay? Okay, producing, okay, non-tester girl, okay? We know that in the reproduction, they have equal chances to get boys and girls. So the probability of getting girl, it is 1/2 or a half. And the same times boy is 1/2 or a half. And since the probability of getting non-tester, as you can see here, non-tester is a quarter. So to get this one is quarter of non-tester times the probability of this boy getting girl is that one. So the probability will be 1/8 probability of getting the non-tester girl. So if you multiply the percentage of how many children, the probability of getting those one percent-wise, it will be like this one, 12.5%. Okay, this Roman 2, okay, this is Roman. Okay, Roman 1, Roman 2, they say it says that a tester girl, to get a tester girl, what is the probability? Tester girl. Tester girl. Okay, as normal, the probability of getting girl, it is a half. Okay, because they have equal chance of getting boy and girls. So to get a tester girl, the probability of tester, as you can see here, is 3/4. The probability of getting girl, okay, is a half. Okay, so tester of getting 3/4 times, okay, probability is a half. That is 2. So when you multiply here, you'll get it is 3/8. Okay, like that one. Okay, so percent-wise, when you multiply by that one, you will get like this one will be, you can do their mathematics. So there you will end up with okay, with that one it is 37.5. okay, I've already done here, it is 37.5%. okay, Roman 3, they are asking to get, what is the probability of getting getting a tester, okay, tester boy, okay, tester boy, tester boy, tester boy. Okay, as normal, tester, the probability of tester is this one, 3/4. Boy, the probability of getting boy, yeah, it is how much? It is a half. So it is 3/4 times a half. That one will be 3/8. So percent-wise, it will be equal to this one. So it is also 37.5. So percent-wise. So that is how. This is Roman. It is part B. Let me finish with part C, which says this. Question number 3, part C. Okay, part C. Part C. It says like this one, okay, it says, what is probability that their first 2 children will be tester of any sex? Okay, 2 children, okay, to be tester of any sex. Any sex. It means boy or girl. Okay. So the probability of tester, okay, is 3/4. If there are 2 children who are tester, it means it will be like this one, 3/4, that is first child, times 3/4, the second child, 2 children to be tester. Okay, that one will be 9/16. So this is probability of getting the tester, 2 children who are tester of any sex. Okay, because 3/4 is any sex. So if you do like percent-wise times 100, okay, that one will be, okay, you can calculate there, we're using calculator, but I've already calculated here. That is 56.25%. So that is question number 3. Okay, so I will end here today.